Share with us on #LearnOn1. Tell us what you're learning and where you're learning it from. Send us your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
Grade 12s. In the previous lesson, we had a look at the charging and the discharging of the lead acid cell. Okay? So the next section of work that we have to go and have a look at is something called reduction and oxidation. The other day over here. All right. And a reduction oxidation reaction is called a redox reaction. The RED for reduction and the OX for oxidation. Now what does it mean? Now in grade 8, I think we started off with the different types of chemical reactions. And we said when something reacts with oxygen, it is an oxidation reaction. Does it sound familiar? Okay. Now, that definition for oxidation is slightly limited. Oxidation can also occur when, for example, a metal like potassium reacts with chlorine. Then the potassium has also oxidized, but there's no oxygen involved. So there is a better definition for oxidation. Oxidation is very simply when something loses electrons. For example, I can have zinc and it can form zinc ions and there go the 2 electrons. That is an oxidation reaction because I start out with my reagent on this side and my product on that side. We see the reagent has lost its electron. Okay? The opposite of oxidation is reduction. Now when we did the chapter on metals and we had a look at the extraction of metals, they commonly use the term the reduction of iron from its ore. Alright? And you could just very simply explain it in terms of you start with this mass of ore that once you've reduced the iron from it, you're only left with a little bit. But that's not the proper definition for reduction. Reduction is just very simply a process of gaining of electrons. So here we have an electron transfer reaction. So a redox reaction is an electron transfer reaction. Okay? How does the electron transfer occur? Well, it goes from the one that loses electrons to the one that will gain the electrons. For example, I can have copper 2+ and it's going to pick up 2 electrons and it's going to form copper. So this is reduction and that is oxidation. And where did the electron go? From the part that was oxidized to the part that was reduced. Now we use the terms reducing agent and oxidizing agent. Now, don't get confused. Oxidation is a loss. The O for oxidation is the O in loss of electrons. Then reduction has to be the gaining of electrons. Now we differentiate with the terms reducing agent and oxidizing agent. The oxidizing agent is a substance that causes something else to undergo oxidation. In this reaction that I've got over here, the copper is the oxidizing agent because it causes the zinc to give off its electron. Okay, in the zinc copper cell, we said the more reactive metal loses its electrons. The zinc is more reactive, it loses its electrons because they fight over electrons. So the copper ions will be the oxidizing agent. The zinc will be the reducing agent. So just to make it complicated, reducing agents themselves undergo oxidation, and oxidizing agents themselves undergo reduction. Will you remember that? The reducing agent causes something else to be reduced. Okay? Itself will be oxidized. The oxidizing agent will cause something else to oxidize, but itself will undergo reduction. All right. So, during a redox reaction, there is a transfer of electrons from the reducing agent. Now remember, the reducing agent undergoes oxidation, loss of electrons, to the oxidizing agent, which will gain electrons. All right. When we go and have a look at the extraction of metals from their ores, a redox, a reduction oxidation reaction occurs. Now, you know a reaction with oxygen is oxidation, so the carbon monoxide is oxidized to form carbon dioxide, and the iron in the ore is going to be reduced to the metal. But how do we see this? Now, I'll come back to this in a moment. We work with something called the oxidation state. And technically, you've actually been working with it since grade 9 when you did ionic bonding. Because what do group 1 metals do? When they form ions, they lose 1 electron. Group 2 metals lose 2. Group 3 lose 3. Okay, leave group 4. Group 5 gains 3. Group 6 gains 2. Group 7 gains 1. So the oxidation states of these elements, group 1 elements will have an oxidation state of 1, 2, 3, they are 4, whether it's plus or minus, doesn't matter. Then we have -3, -2, -1. Why is the charge important? Yes, it shows me whether electrons have been lost or gained. Okay, that is the simple oxidation states. Now it becomes slightly more complicated because we get things like a sulfate ion, something like SO4, but we also get SO2, sulfur dioxide. So the oxidation state of the sulfur differs in the two compounds. All right? How do we work it out? That is what we are going to go to. So the oxidation state is simply the charge that an atom would have if the compound was made up out of ions. Okay, so for example, water, it's covalent, there aren't charges, but the oxidation state within that chemical structure, hydrogen is a group 1 metal, it'll have a charge of +1. Oxygen is a group 7 non-metal, it'll have a charge of -2. That would be the oxidation state of the elements. So here are a system of rules. Now at this point, the ordinary levels, you don't need to worry too much if you've understand about the group number and the oxidation state. All right, they won't ask you much more than that. So at this point, you can do something else, and the higher levels I will carry on with. The first rule, the oxidation state of an element in its free or uncombined state. For example, if I have zinc, okay, the oxidation state is 0. It hasn't lost or gained electrons. Okay? So, they say it's true for all the elements found in nature that are diatomic. The oxidation state then is 0 as such. Rule 2, the oxidation number of a monoatomic ion, monoatomic, 1 atom, is the same as the charge on the ion. For example, group 1 metals have a charge of +1, group 2 metals +2, group 3 metals +3, group 6 elements -2, group 7 elements -1, as we get them on the periodic table. When we have a compound, the sum of all the oxidation states must equal 0. For example, if I took water, the oxidation state of the hydrogen is +1, but how many of them do I have? 2. And the oxidation state of oxygen is -2. So the total of the sum, if I add them together, is 0. Does it make sense? When you were in grade 8 and you had to write the formula, I said to you, for example, the formula of aluminium oxide, we said aluminium is +3 and oxygen is -2, so I need 2 aluminiums but 3 oxygens. You were actually working with the oxidation state, you just didn't realize it, or I didn't explain it to you at that. Okay? Have a look. In this compound of aluminium oxide, aluminium has an oxidation state of 3. There are 2 of them. So that is +6. The oxygen is -2. The bracket is in the wrong place. And I have 3 of them, so it's -6. And +6 and -6 gives me 0. So that is what I mean. If I have a compound, the total of the oxidation states is 0. And now it becomes more complicated, because when we go and have a look at the polyatomic ions. Okay, what are polyatomic ions? More than 1 atom ions. Eh? Something like sulfate, carbonate, hydroxide, phosphate, nitrate. Those are the polyatomic ions. Now, if we go and have a look, here I've got the sulfate ion as an example. The sum of the oxidation states must now equal -2. Because I have an ion, it's not a neutral compound. I have a charge that is a resulting charge. So when I add the charges of the elements together, I must get that resulting charge. So, if I have sulfate, in sulfate, sulfur lies in group 6. So I know sulfur will have a charge. No, we can't work out the sulfur. We must look at the oxygen. So sulfate -2. Oxygen has a charge of 2, -2. How many oxygens do we have? So I have -8. Now my sum must equal -2. So -8 plus what will give me -2? +6. So the oxidation state of the sulfur in the sulfate ion is -6. Oxygen. Usually. Okay. If we look at sulfur dioxide, remember, sulfate SO4 -2, we get SO3 -2, that's sulfite. Eh? What's the oxidation state of that sulfur? Well, 3 oxygens gives me -6, plus what will give me -2? So there it is, plus 4. In the sulfur dioxide, the gas, what's the oxidation state of the sulfur? No, we have SO2, so oxygen is -2 and there's 2 of them, so it must be -4 because this thing overall has no charge. It is +4. Sulfur is +4. Oxygen is -4. Okay, sulfur then has to be +4. Are you following me? Okay. So that is, okay, now the fourth rule. Those rules we use quite often. Now the fourth rule, the oxidation number of an alkali metal, group 1 is +1, group 2 is +2. The oxidation state of oxygen, specifically oxygen, in a compound is usually -2, but there is an exception. What is this? Peroxide. What's the oxidation state of the oxygen there? Hydrogen is +1. We have 2 of them, so we have +2. So the oxidation state of hydrogen there is -1. So the exception is oxygen is always -2. Okay? But when it goes to the peroxides, now we won't work a lot with the peroxides. They probably won't ask it. It's just to be thorough. Okay? The oxygen will have an oxidation state of -1. In other words, the oxygen can be bonded onto fluorine, and then the oxidation state is +1 for fluorine. Eh? Okay, rule 6, oxidation state of hydrogen in a compound. It's always +1. It falls under the group 1 elements. Is daar nog daar? No, next page. If the hydrogen is part of a binary metal hydride, we won't work with this. This is on a very advanced level. Okay, a compound of hydrogen and some metal, then the oxidation state of the hydrogen is -1. Our syllabus does not cover that. So you can just simply ignore that one. Okay? Rule 7, the oxidation state of fluorine is always -1. It lies in group 7. Chlorine, bromine, and iodine also -1 unless they are in combination with oxygen or fluorine. And once again, our syllabus does not extend to those reactions. Okay. So this one we will also not worry about. So here is just a short exercise. I want to do it with you. Determine the oxidation state of the following substances. Sodium, an uncombined element, would have an oxidation state of? Zero. Okay. We have an element, sodium, doesn't have a charge. Okay, so its oxidation state is 0. Magnesium, yes, it's an uncombined element. It's 0. The next one, nitrogen, also 0 because it's a diatomic element. All right, aluminium. I have got the aluminium ion. In other words, it's something like aluminium oxide. What is the oxidation state of the aluminium ion? +3, yes. All right. Yes, because it comes from the group on the periodic table. And we've been doing it since grade 9. Okay, so you should know that. Then, carbon in carbon dioxide, CO2. What's the oxidation state of oxygen? -2. We have 2 of them, so it's -4. So what is the oxidation state of the carbon? Yes, +4. You all with me? Okay, so even Mal, +4. All right, So the oxidation state of carbon is +4. If we go and look at the carbonate ion, there, now we've got CO3 -2. What is the oxidation state of the carbon? Well, oxygen is -2 and there is 3 of them, so that gives me -6, but this altogether must equal -2. So what is carbon? It is going to be +4. Yes. Happens to be the same. No? Yes, in the carbonate ion. All right, then, look at carbon monoxide. I haven't got it there, but just look at carbon monoxide. What's the oxidation state of the carbon? Oxygen is always -2, so the carbon is +2. Are you following me? It's not that difficult when one gets into it. Okay? Just here and there a catch. Okay, then, here's a difficult one. Okay, now the manganese ion, manganate. The manganese in the manganate, potassium permanganate, KMnO4, the permanganate ion. Okay, that's the purple stuff that makes the water purple. MnO4, it has a charge of -1. So, what is the oxidation state of the manganese? Oxygen is 4 times -2. That gives me -8. We must equal -1, so I need +7. Because it's a polyatomic ion, you must go and learn it. Okay? If I said to you, we have got manganese oxide. What's the oxidation state of the manganese? Yes. Oxygen is -2, so manganese must be +2. Can you see that that one and that one have different oxidation states? What was one of the properties of the transition metals? They have got different oxidation states, or they can have more than one oxidation state. Do you understand that now? No, I didn't explain it at that time. I just said it means it can have a different charge. Okay. I think we have one more example. Yes, the nitrogen in the nitrate ion. So, I have got the nitrate ion, NO3. It's a polyatomic ion. Okay. Oxygen is -2, so that must be -6. It must equal -1, so the nitrogen? Yes, +5. Following me? All right. If I have nitrogen dioxide, what's the oxidation state? -4 +4. Okay? If I have dinitrogen oxide, what's the oxidation state? Yes, that's -2. That would be +1, because I have 2 of them. It will give me +2. Okay, are you okay with the oxidation states? All right, we can carry on. Now, so here is a very well-known equation at this point, because we've done the extraction of metals. Now, indicate to me the oxidation state of the oxidizing agent and the reducing agent. Also, indicate the number of electrons either given off or taken up. Now, you have to be a little bit awake. So in your head, when you look at that, you must actually see the ionic equation. We have 2 of them, and that's going to be +3, and we have got 3 oxygen -2s. Do you agree with me? Okay? The ionic equation. I've just broken it up into ions. All right? By carbon monoxide, well, it's easier to see because the oxygen is -2, so the carbon is +2. All right? Yes, we'll balance it in a moment. What's the oxidation state of the ion over there? Uncombined state 0. All right? And over here, what is the oxidation state of that carbon atom? Now we have -4, so it is +4. So now, Can you see that the iron goes from +3 to 0? What must anything do to go from +3 to 0? Gain 3 electrons. Remember, electrons are negative. So, what do we call the gaining of electrons? Reduction. Okay, 3 electrons. But if we look at the balancing, then we have 2 ions. So, I must multiply the whole thing by 2. Yes. The iron is the oxidizing agent because itself undergoes a reduction. Are you following? All right. Now, let's use a different color. We find that the carbon over there and over there, here the oxidation state of the carbon is +2, and over here the oxidation state of the carbon is +4. Well, for anything to go from +2 to +4, it must lose 2 electrons, and the loss of electrons is oxidation. And we have 2 electrons. But now let's just go and balance it. How many carbons have I got there? 3. So I must multiply 3 times. So, how many electrons are given off in total? 6. How many electrons are taken up in total? 6. You can't have electrons floating around in the air. They must physically, they don't dissolve and they don't float in the air. They must go from one substance to another. All right. So here we have indicated which parts have undergone oxidation, which parts have undergone reduction. If you go and have a look at the oxygen in all of these compounds, what's the oxidation state of oxygen in this compound? -2. What's the oxidation state in that one? -2. And what's the oxidation state in that one? -2. Did the oxygen as such take part in the reaction? No. Now we can go on to the next part. Now your syllabus refers specifically to the to specific oxidizing agents and to specific reducing agents. The potassium permanganate is one. Acidified potassium dichromate is the other. And you must know or be able to recognize these reactions as well as their color changes. That's very important. All right? Now, if we go and have a look, if I look at the compound potassium permanganate, if I break this thing up, this is an ionic compound. So if I break it up into ions, I have a potassium ion and a permanganate ion. Okay. The potassium is +1. And if you go and look on the opposite side of the reaction in which it's occurring, I've only got the half reaction here, then you will see the potassium stays +1. It's like it doesn't react. I could have just as well had sodium permanganate. You understand? All right. Okay. Now, let's have a look at the oxidation reaction of potassium or the permanganate ion. Here I've only got the permanganate ion. I've taken away the potassium there. But because I've taken away the potassium, it now has a -1 charge. You follow? So, what is the oxidation state of the manganese ion in the permanganate? Well, oxygen is -2. There are 4 of them. So it gives me -8, and I must have a resulting charge of -1. So, manganese is +7. Okay? So, if we go and look at the manganese ion that is now formed, well, the oxidation state is +2. +2. It's indicated. To go from +7 to +2, what must it do? Gain electrons. How many electrons?
5.
Yes, it must, oh, there I've got it. Gain 5 electrons. The permanganate ion has a purple color, and the reduced manganese ion is colorless in solution. So if you have potassium permanganate, and for example you bubble a reducing agent through it, something like hydrogen sulfide, we will see there's a color change from a purple solution to a colorless solution. All right. The next one that we have to have a look at is the dichromate. This is the permanganate ion. Okay, permanganate ion. And this part, the Cr2O7 part there, is the dichromate ion. It's also just a polyatomic ion, one that you just don't work with all that much. So now if we're going to have a look at the oxidation state of the chromium in the dichromate ion, we will find, well, oxygen, 7 of them is -14. I must have a resulting charge of -2. So the chromium, there are 2 of them, has got to be 2 times +3. No? 6, 12. It must be 12. 2 times +6. So the chromium ion has an oxidation state of +6. If we go and look at the chromium ion over here, it has an oxidation state of +3. Well, to go from +6 to +3, it needs to gain 3 electrons. Gaining of electrons is reduction. The dichromate color is a very bright orange, like this Fanta tin orange. Okay? A bright orange. This ruler is bright orange. It's the dichromate color. The chromium ion is green. So, if we are busy with the reduction-oxidation reaction, and I have something that changes color from orange to green, a good guess would be, what have I got? Dichromate. Okay? Are you with the reduction-oxidation reactions there? Okay. So, these 2 oxidizing agents, they themselves undergo reduction. You need to know them, you need to know the number of electrons, and you need to know the colors, because they use it when they describe a reaction that's occurring. And if you don't know it, then you're lost, then you don't have a clue of what the reaction is that is happening. All right. And the syllabus is specific with respect to these 2. Okay. Next page. Now, reducing agents themselves undergo oxidation. Now, your textbook refers to specific reducing agents, all right, of which one of them is the iodide ion, and it will form iodine. The oxidation state of the iodide ion is -1. The oxidation state of iodine, an uncombined element, is 0. What has happened? Well, to go from -1 to 0, it must lose 1 electron. In other words, oxidation has occurred. Now, the iodide ion, for example, of iodine, if I dissolve it, what is the color, or a reddish-brown solution? Be very careful. This iodine. If they work with iodine crystals, what is the color of iodine crystals? Purple. Yes. Okay. Shiny, dark, purple. So don't let that confuse you. This is in solution, this color. Okay. The next one is iron 2 is converted to iron 3. Where have we worked with iron 2 and iron 3? There where we tested for the different metals? When we added sodium hydroxide or ammonium hydroxide? Iron 2 is what color? It's got 2 E's, green. Iron 3, what's this? Yes, the stuff that lies around outside on the iron. Rust, reddish brown color. So that's one you should know. Okay, so oxidation state is +2 there and +3 there. So to go from +2 to +3, it must lose 1 electron. This will be oxidation, and the color change, very characteristic, is from green to reddish brown. So if I tell you of a solution and I bubble hydrogen sulfide through it, and, oh no, it won't work with hydrogen sulfide. If I add some potassium permanganate, and I will get a green color changes to red-brown. What have I got? Probably this. That's the only part where we really work with color. Okay, now, the next one, all the halogens work like this: bromide, iodide, chloride, fluoride. They can all be oxidized. So here the oxidation state is -1. There it's in the uncombined state, so it's 0. To go from -1 to 0, it must lose 1 electron. So to balance this equation, because I have 2 bromines there, I need 2 over there. So I would multiply that with 2 because I have 2 bromides. The color of bromide is colorless. Potassium bromide is colorless. The color of bromine is a reddish brown liquid. Remember the halogens? Fluorine is yellow. Chlorine is green. Bromine is red-brown. Iodine is purple. Unless it's dissolved in water, then it's reddish brown. Okay. Hydrogen sulfide. If I have H2S, it's a gas. This gas got the smell of a rotten egg. If you break a stink bomb, there's something that gives off some of that gas. Yeah, that is what it smells like. So this gas, it's a colorless gas. We can't see it, but we can very definitely smell it. So, if they tell you a smelly gas, which 2 smelly gases do we work with in our syllabus? Ammonia and hydrogen sulfide. So, the sulfide ion has an oxidation state of -2. The sulfur has an oxidation state of 0. So to go from -2 to 0, it must lose electrons. And it's going to lose 2 electrons, so that's oxidation. So sulfide is oxidized to form sulfur. Now, this one is colorless. And who knows the color of sulfur? Yellow. You can buy it at Agra. Blomswaal. Yes, okay. It's a yellow substance. Usually we buy it in the form of a powder, but it can be a solid that you can grind up to make the yellow powder. But it's a very characteristic yellow. There's nothing strange about it. No. Okay, so that is the reduction oxidation reaction. Those are the ones that you must know of, specifically the color changes. Okay. Now, here we have some examples. Reduction, oxidation half reactions. Iron oxide reacts with carbon monoxide to form iron and carbon dioxide. Look what happens. What is the reduction reaction? In other words, that's the oxidizing agent. The iron 2 gains 2 electrons to form iron. The oxidation reaction, in other words, that's the reducing agent, goes from carbon monoxide, it gains it loses 2 electrons, and it forms carbon dioxide. All right, now, in your books, the first one gives me 2 potassium bromide. Maybe I should use color, then it will be maybe more clear. Potassium bromide plus, let's do chlorine in blue, Cl in blue, and we get potassium chloride. We get potassium chloride, 2 of them, plus bromine. Now, can you see that the potassium can actually be removed because the potassium did not really take part in the reaction? But just let's bring that one back over here. Can you see that in this one the potassium will be plus 1 and the chlorine is minus 1? Okay, I'm just going to put this potassium back over there and come here. There we go. All right. We aren't going to work with the potassium. We can try. I can go and write down the oxidation state of all the elements that I have. Oxidation state of potassium is plus 1. Bromine is minus 1. Chlorine gas, 0. Potassium, plus 1. Chlorine, minus 1. Bromine, 0. Which one didn't change? Potassium. So that didn't take part in the reaction. It could have been sodium. We call elements like that are just there. We talk about spectator ions. What do you want to say? Well, no. They don't take part in the reaction at all. They just happen to be there. Okay. Spectator ions. They sit around looking at what's happening. They don't take part. Okay. So, where is my oxidation and where is my reduction half reaction? Well, if we go and look at that one, is where the one will fit. And if we look at that one, is where the other one is. Do you agree? The half reactions. Okay? To go from minus 1 to 0, what must happen? Lose an electron. So there is my oxidation reaction. If we look at the chlorine to the chloride, we will find it goes from 0 to minus 1. What must it do? It must gain an electron. There is my reduction reaction. So that's 1 electron there, and that one is also 1 electron there. If we go and have a look at the balancing, then can you see I have 2 over there? And I have 2. So I must multiply this whole thing with 2. Sorry, I'm on the wrong one. This whole thing here must be multiplied by 2, but the other one is the same. So it's also multiplied by 2. So in total, how many electrons are given off? No? 2 are given off and 2 are taken up. All right. Okay.
Will you wash your hands with me? I want to wash my Wash your hands in clean water. Wash your hands, wet them with the water. Wash your hands, now add some soap. Scrub your hands in the soap and water. Scrub above and below between the fingers too. Scrub under your nails and scrub-a-dub-a-doo. Rinse your hands in water. Rinse them clean, rinse away the soap. Dry your hands and go.
Achille, why do we wash our hands?
To wash away the germs.
Achille, what are germs?
They're like tiny little bugs on your hands and they can make you sick.
But I don't see any germs on my hand.
That's because they're so tiny that you can't even see them.
Oh wow! I want to wash the germs away. Will you wash your hands with me, Achille?
Of course! Wash your hands in clean water. Wash your hands, wet them with the water. Wash your hands, now add some soap. Scrub your hands in the soap and water. Scrub above and below between the fingers too. Scrub under your nails and scrub-a-dub-a-doo. Rinse your hands in water. Rinse them clean, rinse away the soap. Dry your hands and go. Great job, Haruma! Can you tell me the 4 things we did to wash our hands?
I can try.
1.
Wash our hands with water.
2.
Put soap on our hands.
3.
Scrub our hands all over.
4.
Rinse our hands clean with water.
That's right! You got it! Wash your hands, wash the germs away.
Share with us on #LearnOn1. Tell us what you're learning and where you're learning it from. Send us your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
Namibia is known for its beautiful wide open landscapes. However, these deserted spaces also pose numerous educational challenges in our country's rural areas. Because of this, many learners are denied access to proper teaching and learning. At EduVision, we believe that education is the starting point to a journey of endless possibilities. It is EduVision's goal to prepare and guide learners in order to make the modern world they are living in accessible to all.
We always love to hear from you. Send us your views, comments and videos with your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
Namibia is known for its beautiful wide open landscapes. However, these deserted spaces also pose numerous educational challenges in our country's rural areas. Because of this, many learners are denied access to proper teaching and learning. At EduVision, we believe that education is the starting point to a journey of endless possibilities.
Soon and very soon, soon. We are going to see e-learning. Soon and very soon. We are going.
The plan for EduVision was to identify areas in Namibia that did not have the proper learning resources, a working school or an education center.
Hallelujah, hallelujah, we are going to see e-learning. No more.
My name is Philip Smith. I'm the principal of Educate Academy in Otjiwarongo. The project EduVision, the e-learning program, started in 2017. With a project like this, obviously telecommunication, internet connection is a major thing that needs to be sorted out, a logistical challenge. And the fact that we chose Chunkwe Secondary School as the first school didn't make it easier for ourselves. It's very far from Otjiwarongo, it's far from Windhoek. So the internet connection was a big challenge first of all. So with the help of the telecommunications expert Paratus, they made this dream come true with internet connections via Windhoek, Otjiwarongo to Chunkwe and then back, the whole process. Like I said, it's interactive whiteboard, so the internet speed, capacity of the connectivity and so forth plays a major role. And so Paratus made this dream come true, and they were on board from the first moment. So very grateful for Paratus.
The project offers teaching assistance of a high standard in science to rural secondary schools within the learner's own community by means of e-learning. This entails the following: live transmissions of lessons from an equipped teacher in a different location to the students in rural areas, students using their own cell phone, tablet or computer to recall each lesson, and interactive lessons as well as the use of a smartboard as a teaching aid.
So if you look ahead at the next 3 years, we get information from the Ministry of Education. The future is very bright. So I think there's a lot of schools who can benefit from this program. Like I mentioned before, finances obviously plays a major role in a project like this. So we're very thankful for all the sponsors that are on board and still on board after almost 3 years of the project. So as long as people from the private sector can get involved, I think we can reach many schools in Namibia, because this project made a good start now. We're already seeing some positive results, and we can just call on all the private sector corporate sponsors to come on board and join in this very, very positive project.
It is EduVision's goal to prepare and guide learners in order to make the modern world they are living in accessible to all.
My name is Magdalena Neoma. I'm 18 years old and I'm doing my first year at UNAM Commandstown campus, and I completed my grade 12 at Chunkwe Senior Secondary School. I'm doing education, so I'm gonna teach at Chunkwe Secondary School, because there I really need to go there and motivate the learners. EduVision helped me a lot. It assisted us in teaching for mathematics, physical science, and biology. And it also, we get to exchange learning from other schools like Educate, whereby they teach us, and that's the most thing that we benefited from. Studying without education was so challenging. And when education was introduced at our school, things become more easier. The time where education was not introduced, we were so slow in learning. And when education came introduced at our school, my learning speed increases. Things were kind of boring. And when education came, my mind changed the way I think. I'm really grateful for what education gave us. Our class of 2019 was the first group to make it, to perform very well at Sunko Senior Secondary School. So it should keep up the spirit. We need that. It should continue to support us.
EduVision aspires to ensure that equal opportunity is offered to every learner in rural areas to tap into his or her own potential while working in an environment which views disadvantages not as obstacles but as unique attributes that can be regarded as powerful assets when given the proper opportunity. At EduVision, we believe that dreams are the foundation of knowledge and hope always triumphs over experience.
No more problems. Everything is proper. EduVision, baby.
Catch a weekly rerun of Today on 1 every Saturday morning from 9 to 11:30.
Today on 1, always there.
Far away, so far away, far away, so far away.
Kashishipu, so tuli moju.